Hey guys, welcome to 9.3. And in 9.3, we're going to be predicting how reactions are going to occur. So essentially, I'm going to give you the reactants of a chemical equation, and you and I are going to figure out what's going to be produced from that reaction, okay? So the first thing we do is we need to identify the type of reaction that's occurring. Why is that important? Well, different types of reactions are going to produce different products. So we have to examine the reactants first. So these are the three types of reactions that you will be expected to be able to predict. Notice there are two that are not on here. That's synthesis and decomposition. We won't be predicting those products, but you will predict the products of these three different types. So when we go through these different reactions, we need to identify which reactions occurring, and then we can look at the rule. If you identify the reaction to be a single replacement, meaning that there's a single element on one side and then there's a compound, okay? So if it's single replacement, you have to follow this rule. It's called the activity series rule. The activity series is listed down here, and it shows all of these metals that react in single replacement reactions. Their reactivity increases as you go up, but I also like to say their attractivity increases as they go up. For example, in a single replacement reaction, you know that single element is going to switch places, right? So you have a single element and then you have the compound, and that single element switches places. It kind of steals the other guy's girl. Well, that doesn't always happen. Sometimes if you have a single element and a compound, the single element will not steal the other guy's girl. So how do you know when that's going to steal and when it's not going to steal? Well, it's all about their attractiveness. Metals at the top are more attractive. So the more attractive or reactive the element is, then it's going to steal the other guy's girl. Attractivity increases this way. But if it's down here, like gold is the least attractive, that means it will never steal the other guy's girl. So how does that work? The more reactive element will replace the less reactive element, or the more attractive element will replace the less attractive. There's metal A and metal B, and B is combined in a compound with the girl, okay, which is usually the non-metal. And we want to know, is it going to produce something? Like, is it going to react? Well, let's pretend that A is higher up. Let's say A is over here, and let's say B is down here. If A is potassium and B is magnesium, then A is more attractive, okay? So if A is more attractive, it will switch off and take the compound. It will form, they'll just switch off like this, okay? But let's say A is still more attractive. Let's say A is with the compound, okay? And let's say A is more attractive. If A is more attractive, it's going to stay with the girl, and B will not be able to switch it off. So remember, B is less attractive. It's lower on the scale, so it cannot beat A, okay? So we would put no reaction if the single element right here is less attractive or it's lower on the scale. That means it's not going to steal the girl, so no reaction will take place, okay? The decomposition rule, oh, it's not decomposition, I'm sorry. This should say double replacement. I believe your notes say double replacement, but if they don't, change it. Double replacement. So remember, we know it's double replacement if there's two compounds at the beginning. So if there's two compounds at the beginning, like this, here's AX and here's BY. These are the two compounds. Then they're just going to switch places. So A is going to take B's place and B is going to take A's place. You do not need to look on the activity series to see if this is going to happen. We're always going to assume that this will occur. So we'll always switch them, and so A will be with Y and B will be with X. Okay. The combustion rule is you'll have some compound here and then you'll have oxygen. So if you see something combining with oxygen, you know it's going to produce carbon dioxide gas, and it's going to produce liquid water, okay? Always. So these are always your products in a combustion reaction. Before we move on, I have to review diatomics for you. Diatomics are on the periodic table. Okay, so diatomics mean anything that is made of two atoms. Di means two, atomic means atom, so two atoms. So if I was to write something that was a diatomic, it would look like this. I would put a little 2 at the bottom representing those two atoms. Hydrogen is a diatomic. So anytime hydrogen is by itself, it's going to have the 2 at the end every single time. For example, if I was to make water, I don't write H plus O, I write H2, okay, when H is by itself. But if H is with another compound, then you even out the charges to find what the subscripts are. But if it's by itself, it's going to have a 2 at the end. Now, we also have a group of diatomics that form the number 7. All of these here form the number, it looks like the number 7, and they start at the 7th element. So hopefully that's a reminder. They start at 7 and they form a 7. All of these are diatomics. So if N is by itself, you have to put a 2 here. If F is by itself, you have to put a 2 here. If O is by itself, you have to put a 2 there. Cl is by itself, you have to put a 2 there. These are diatomics. You have to memorize them. So anytime you're writing a reaction and you're writing the products, okay, if one of your products is chlorine with another compound, you can't just write Cl like that. You have to write Cl2, okay, because it's a diatomic, which means if it's by itself, it has to be with another chlorine, okay. So let's do this first one together. All right, so I'm looking at this, and the first thing I have to do is identify what reaction this is before I can even identify the compound. Well, I see that I have a single element. This is a single element, and then here's a compound. What type of reaction will occur if there's a single element and another compound? Okay, we know, we've memorized this from 9.2, and that is a single replacement reaction. Anytime you have a single element in a compound, it's going to form a single replacement reaction. So what happens in a single replacement reaction is the single element will take the place of the element at the beginning of the next compound. Only if the single element is more attractive. So I have to look on my scale here, and I have to make sure that nickel is higher than copper on the attractive scale. So I look and I find copper's down here. Okay, here's copper. And now I have to find nickel. Nickel is more attractive than copper, so nickel will get the girl. The more attractive element will get the girl. So if I come back over here, nickel's more attractive, so nickel will get the girl. So I write nickel with the girl. Nickel with the girl. And then I'm going to write copper at the end. Cu, okay? Now, we have to even out charges. Copper's by itself, since it's not a diatomic, I don't have to put 2 at the end. I just write Cu. But nickel and chlorine, I have to even out the charges. Nickel's a transition metal, so I'm just going to tell you right now, its charge is +1, okay? If I give you one of these, I will always give you the charge of the transition metal. You'll never have to calculate it yourself. So nickel's charge is +1. Chlorine is in group 17, so its charge is -1. See how those charges even out? We don't need to add subscripts now. Okay, so that's the first problem. Now let's move on to my next problem. If I'm looking at this, I have to figure out what type of reaction this is. This is a single element, and then this is a compound. So if it's a single element and a compound, I know it's a single replacement. Single replacements mean the single element will want to steal from the other element at the beginning of the compound. So copper is going to want to steal from iron, but copper can only be with a girl if copper's more attractive. So I have to make sure, and I keep saying attractive because it makes sense with relationships in your everyday life, but really what I'm saying is copper has to be more reactive, okay? The reactivity scale. So copper and iron. Down here, here's copper, okay? And then here is iron. So which one's more attractive? Iron is more attractive. So iron has to be with the girl. If we look, iron is already with the girl, okay? So copper cannot steal, so we have to write no reaction. No reaction will occur if the more attractive one is already with the girl, then he's not going to give out the girl, okay? So no reaction is going to occur. Now let's look at our next example. This one, we have a compound and a single element, so you might think it's single replacement, but this element is oxygen. Remember, anything reacting with oxygen is going to be what type of reaction? Combustion. Okay, so if the compound is reacting with oxygen, that's when it's a combustion reaction. So we know from our rules above that combustion reactions will always produce carbon dioxide gas and water. And usually that water will be a gas as well, like a water vapor, okay? So this combustion reactions are the easiest ones to write products for because you don't have to even out charges because you already know the formulas. All right, we got 2 more. So this one on the bottom has a compound and another compound. So if there's two compounds, we know it's double replacement. Okay, so I look here, and in double replacement, you always have the first element will take the other first element's place. So Ba is now going to be with PO4. Okay, now H is going to switch places, and it's going to be with chlorine. So I'll have H and Cl. Now, here's a common mistake. Kids are going to see the 3 next to the H, and they'll put the 3 here, but that's not what you're supposed to do. You cannot take the subscripts with you. You have to come up with your own subscripts. The only reason the 4 is still here is because it's part of the formula PO4. It's part of that polyatomic, okay? So, how do I find the subscripts that are going to go on this side? I have to even out charges. Barium's charge is +2 because it's in group 2. PO4 on the polyatomic chart, its charge is -3. They don't even out, so I have to add 3 bariums and 2 phosphates to get the same. You see how my charges are the same now? So since I had 3 bariums, I put a 3 here. Since I have 2 phosphates, I'll put a 2 here. Notice I did not take my subscripts from the other side and move them over. You have to even out your charges. H's charge is +1 and chlorine's charge is -1, so I don't need any charges down here, so I don't leave them. Notice I don't take my 2 or my 3 and add them on. I'm not putting 3 and 2 here, okay? You can't move over your subscripts. You have to even out charges to find your subscripts, okay? So that is the reaction for my double replacement. And we have one more. HCrO4, that is a compound, and NaOH is a compound. So that means it's double replacement. So before I can even predict my products, you have to know what kind of reaction it is. Since it's double replacement, the first element is going to replace the first element of the next compound. So this is going to be HOH, which, by the way, if you ever end up with HOH, you're going to form water every single time. So don't worry about evening out charges. You just write H2O. Okay, now sodium is going to replace hydrogen, so it'll be sodium. Whoops, I'll just write it down here. Sodium chromate. Okay. And again, the only reason I'm taking this subscript here is because it's part of CrO4's formula, okay? So I have to even out charges. Sodium is in group 1, so it's +1. Chromate is a polyatomic. Chromate's charge is -1, so they're automatically even. So H2O and NaCrO4 is are my products for my double replacement reaction. That is it for 9.3. You have several on your own problems. I want you to try them. Each of them is a different problem, a different reaction. So make sure you identify the reaction first. So look through and find all the single replacements. Then find all the combustions and find all the double replacements. And then once you know the type of reaction, you're going to go ahead and predict the products. All right, and that's it. Y'all have a fantastic day.